To an outsider, the realm of academia may seem opaque and stuffy. Lingo such as papers, journals, peer review, preprint, postprint, etc. are not always understood. The public at large often find they have no access to scientific works. They are often met with demands for eye-watering fees to purchase the PDF, seemingly counter to the aim of reproducible results, free thought, questioning, and open communication we are taught are fundamental to science. This touches on a thorny and growing issue in science for both scientists and the public at large. The fundamental questions facing the scientific machine now are: how should research be disseminated? Who should pay for publication costs? What should the price of publishing be? How can the public be allowed to participate? What is the cost of open science? In this video, I'll try to shed some light on what publishing in science is, what the costs are, and why open access is important for us all. To understand how we got here, let's start by busting some jargon. Publishing in science means that a piece of research, an experiment and/or argument, is physically or digitally printed in a periodical called a journal. Journal being in many ways a kind of scientific newspaper, where other scientists can be updated on current thinking and results. Journals typically edit, proofread and typeset articles, with any changes to the scientific content done with reference to peer review reports. Reputable journals will have a rigorous peer review process, meaning if you submit a piece of research, a group of academics in your field will judge the quality of the science, its methods, conclusions, scope and fit for the journal. The idea being that, hopefully, incorrect or bad science won't be accepted, and good science will be accepted for publication, perhaps subject to requested changes. This gives other researchers confidence that, to some degree, the research meets a certain quality of scientific method, although this statement is the subject of other controversies in science, like the reproducibility crisis. Naturally, an entire hierarchy of journals, good and bad, has risen in each scientific discipline dependent on the general quality of their content. This results in immense pressure for researchers to publish in good journals, as a judge for getting research grants and advancing their careers. Again, another potential problem in its own right. The long and short of it is that as a scientist, whether as a biologist, physicist, mathematician, social scientist, psychologist, or any other discipline, you are measured by the quality, quantity, and citation record of your journal publications and books. Publishers publish whilst individuals, research groups, universities, libraries, and research organisations subscribe to many journals, which are read by their academics and students. The way in which a journal publishes scientific articles is highly varied. Some journals are free to read, meaning there is no charge to subscribe and read any article, also called open access. The journal usually charges APCs, article processing charges, to recoup the cost, or in many cases make a profit. These can be hundreds to tens of thousands of dollars per article. Some are free to publish, but not free to read, meaning the author of an article pays nothing, but a reader must pay for a subscription or on a per article basis. Some, of course, are a combination of these. And in any case, sometimes a reader's institution pays for the reading subscription, and maybe even the cost of publishing. Without guaranteed funding or subscriptions, academics must apply for funding or even pay thousands of pounds to publish their work in not free-to-publish journals. The reason for charges are often cited as the peer review process, although peer reviewers are not paid, editorial or administrative costs, as well as the cost of printing in physical journals or hosting costs for electronic journals. It's reasonable that costs be repaid, otherwise no publishing will happen. The question is, of course, how? Due to these possible restrictions and the length of a high-quality peer review process, scientists also often publish preprints to quickly get word out of their current work. A A preprint is a copy of a research paper, generally prior to or at the same time as submission to a journal, originally posted physically to colleagues or handed out at conferences. This is one version of self-publishing. Nowadays, preprints are usually published in online and freely accessible databases for anyone to read, such as arXiv, medRxiv, or bioRxiv. The goal is to rapidly disseminate current thinking in a completely open and free way, with the caveat of pending peer review. The existence of such self-publishing begs the question, why do scientists publish in journals at all? Surely open peer review can be commented and submitted to archival systems to assent or discredit research. For instance, Grigori Perelman contributed outstanding work to mathematics in the early 2000s by publishing only on arXiv. After the mathematics community read and eventually understood his documents, his contribution earned him both the fame of the only to date solved Clay Institute Millennium Prize problem, worth $1 million, and the Fields Medal, the mathematics equivalent of the Nobel Prize. He rejected both. Clearly, it's possible to do the highest quality of scientific research without journals. So how did we get here? In the days of Socrates, Plato and Aristotle, current thinking was set out orally, although sometimes written down in books, or what may be more accurately called personal notes in many cases. Today, a typical researcher presents their work similarly, but in an altogether different manner. Scientists nowadays speaks at conferences, publishes journal articles and or academic books. By far the most extreme difference between them and now is printing. Before the invention of the printing press, any texts had to be written by hand by the author or a scribe and physically copied by hand if needed. After the classical period, scholarship continued, in Europe largely in monasteries by monks such as Bede in the later 600s and Aculeus in the early 800s. Elsewhere, great thinkers such as Al-Khwarizmi in the 800s and the rich tradition of Indian mathematics from about 500 onwards. The first universities and colleges were founded in Bologna, 1088, and Oxford, 1096. These similar institutions began, such as the Kerala School of Astronomy and Mathematics in the 1300s. The real revolution in science began with Gutenberg's printing press in the early 1400s, which allowed any scholar to publish works far faster and with a greater number of copies. Interesting to note is that with this new printing came the importance of publishing. Suddenly the who and the when of knowledge and ideas became important, as well as proper citation. But it was still not until the foundation of learned societies, such as the Royal Society of London in 1660, or the French Academy of Sciences in 1666, that academic journals began to surface, one of the first being Philosophical Transactions of the Royal Society of London in 1665, which is still in print today. You can even read the early issues online. The journal marked the start of a hybrid era of publishing books and publishing journal articles. The history of the transactions of the Royal Society is quite rich and surprisingly well documented. In fact, delving into it really sheds some light on how we got here. Transactions began as a small commercial experiment by Henry Oldenburg, then secretary of the Society, at one point covering his rent. The project, facilitated by his large network of contacts, included summaries of experiments at the Society and elsewhere, book reviews, and adapted correspondence with no formal submission process. During the 1700s, the publication survived on private benefactors and was not an official part of the Society still. One price point cost the journal at £1,500, £300,000 in today's money, over a 20-year period, paid for by Hans Sloane. By the spring of 1752, the Society had agreed that transactions should henceforth be published for the sole use and benefit of this Society, and that the great charge and expense incurred would now be defrayed out of the stock or fund of the Society. This was a general aim of the Society before 1900, the Royal Society supported the publication and circulation of scientific knowledge and did not expect to recoup much of the cost from sales. During the 1800s, mechanisation of the printing process took over and the journal expanded rapidly. By 1820, it was put to the Society by a group including Charles Babbage that Fellows of the Society should be judged by their prior publication record, the birth of publish or perish. As a result, they proposed a more strict system of review of both new members and academic publications in the Society's journals. These intriguing reforms were panned at first, but by 1847 had largely been implemented. In these days, a paper would be reviewed by a committee to determine its worthiness for presentation at the Society in person. These presentations being mentioned in the newly formed journal Proceedings of the Royal Society, which began as a list of abstracts, i.e. summaries, under a different title. The best, subject to a further committee, were accepted for review for potential publication in Transactions itself. That peer review process included a detailed register of submissions, their fate, and a committee responsible for the final decision on receipt of 2 reviewers' reports. The reviewers normally being fellows of the Society. That process of review typically took around 5 weeks, with reports ranging from a few sentences to a dozen pages in length. Even with mechanisation and efficient structure, the ratio of fellows, i.e. reviewers, to submissions quickly dwindled. By the 1920s, funding via government grants and private donation came under strain, leading to a focus on the financial enterprise of publishing, meaning price increases, with the Transactions making a profit again in the mid-1900s. In 2014, the Royal Society, a charity, reported £2.6 million in profit from publishing activities, 1/5 of income. As a registered charity, the Society uses its profits and donations for the public good and promotion of science. The snaking path of journal publishing at the Society, from an informal set of articles published by Henry Oldenburg for a profit, to a formal record of scientific work, reviewed by peers and paid for by private benefactors, and back again to a profitable enterprise of a charitable organisation, is one route how we got here. However, there was another thread: private, for-profit publishing by businesses. The trajectory of the Transactions and Proceedings of the Royal Society, and the Society's other journals, shows the cost of publishing scientific knowledge. Cost is one thing, and turning a profit as a charity, which is then redistributed, is fine. But a new brand of publishing in academia began to take force over the 1900s. Great for-profit publishing houses grew over the industrial era in the 1800s across Europe, just as the learned societies did. One example is the small bookstore and publishing house Julius Springer Publishing House, began in 1842 in Berlin. The company quickly expanded into technical and scientific publications, having already purchased some scientific journals in the 1880s, and expanding greatly into German medical journals in the early 1900s. The 1970s, 80s and 90s marked rapid expansion from Germany across the world for Springer. And by 1990, Springer had established an online platform which allowed users to read and purchase scientific publications online, which of course had nothing to do with the rise in the idea of free open access online publishing in the 1990s. Today, Springer Nature, known for the journal Nature, a UK journal it bought, and Elsevier are the 2 largest publishers focusing on for-profit, i.e. they are not charities like the Royal Society, publishing of academic work. Each make over $1 billion in revenue, with profit margins around 20 to 30%. Both do have the possibility of open access for a hefty levy on the authors of submitted work. Nature, for example, charges €9,500, roughly $10,000, for an accepted paper to be published as open access, and Elsevier charges on average $2,658 across its journals. Knowing the history of academic journals, published by for-profits and not-for-profit organisations, let's talk about open access and open science. Open access of science is the ability for free reading and sharing of research papers. There are many types balancing four pillars: free to read, free to publish, peer review, and authors retaining copyright. For example, in Diamond Open Access, authors retain the rights to their published work. It costs them nothing and costs nothing to read, and the work is peer reviewed. This is rare. In Gold Open Access, the work is free to read, the authors retain copyright, and the work is peer reviewed. However, authors pay to publish. They pay article processing charges. The American Association for the Advancement of Sciences, Science Advances, is one example. For preprints, the work is free to read, free to publish, the authors retain copyright, but there is no peer review, typically. Archive is one example. Hybrid open access is when a journal offers some form of open access in some articles, but closed access for others. Examples are Nature and Science. Many journals, for-profit and not, offer different flavours of open access at significant cost. Some journals are funded by the public purse, taxpayer money. Others charge at cost, i.e. be charging per figure or per page, or a fixed amount. For example, Science, comparable in scope and quality to Nature, from the American Association for the Advancement of Science, is a subscription journal charging roughly $2,200 in subscription fees and charges $650 for the first colour figure and $450 for figures after it to the authors. Archive costs $800,000 per year to host, meaning $10 per article. And on average, fully open access publishers charged $660 per article in 2011. Notably, there is an unclear link between journal prestige and article processing charges, the cost charged to scientists, or subscription costs. In any case, the true cost of publishing at for-profit journals is not known, due to strict non-disclosure agreements imposed on institutional subscribers to journals like Nature, or the majority flat out refusing to provide data on the real cost of bringing articles to print. Nature stated their cost at $30,000 to $40,000 per article in 2013, and now charges $10,000 for open access. Nature will not disclose their profit margins, but Elsevier, of comparable size, profits at 37%, and Nature was estimated at a profit margin of 40% in 2013. It is also widely known that for-profits' profit margins are higher than non-profit scientific publishers, ranging from 20% at learned societies up to 30% and 40% and above in for-profit organisations. For-profits and costly journals would argue they provide a service by rejecting scientific articles, checking for plagiarism, editing, proofreading, typesetting, standardising and distributing. This is true, but it does not justify higher profit margins against open access, university and scientific society publishers doing the same, especially those with similar prestige. Despite this, the fact remains a researcher has every incentive to pay to publish in the most prestigious journals like Nature, open access or not. With closed access publishing, the reader, more accurately the public at large, is deprived. So how can you read papers? Firstly, of course, there are many journals publishing open access articles, or so-called hybrid journals, like Nature, with many articles accessible. Particular gold open access examples are PeerJ for biology and medicine, PLOS ONE, a general science and medicine journal, Science Advances, a general science journal, Royal Society Open Science, another generalist, and Physical Review X, surprisingly a physics journal. Hybrid journals include Nature, Science, Physical Review Letters, and PNAS, to name a few. Secondly, even for closed access articles, pre- or postprints are often accessible. A postprint is similar to a preprint, but it has been peer-reviewed and accepted as a journal. Postprints are sometimes called author-accepted manuscripts. Google Scholar is an excellent way to find preprints by copy-pasting the article title or authors and searching for accessible PDFs. Otherwise, trawling databases like Archive, medRxiv, or bioRxiv will likely bear fruit. Additionally, emailing or tweeting authors asking for the PDF works. Above all, authors want their articles read, and are often allowed to share on a peer-to-peer basis, and often will on principle if they are not. At the end of the line, black open access is the movement of, quotes, illegally sharing scientific articles, e.g. over Twitter or on Sci-Hub. Naturally, phenomena such as Sci-Hub, an illegal repository of copyrighted journal articles, are disliked by for-profit journals. It is considered copyright infringement on the part of the journal, not the authors. Elsevier even sued Sci-Hub in the United States for this. Like piracy, black open access is a problem of availability, with the stakes being access to the collective state of human knowledge. However, unlike video games, movies, TV and music, where the authors directly lose money from piracy, it's just the publishers who lose out financially. If anything, the scientists get more recognition. For this reason, many scientists praise movements such as Sci-Hub in the face of massive journal profits. At the end of the day, science needs to be open. This means open access should morally be the standard. The question is how it can and should be paid for. Partly this question is moot, since large amounts of research funding comes directly from government grants, from taxpayers. And if any taxpayer's money funds a journal article's research, it must be accessible by the public. We could decide as a society to pay for open access via taxes specifically, or leave it to research institutions and their scientists. This begs the question how much open access really costs. Remember, Nature, which is for-profit, charges $10,000 per article. Science, which is not-for-profit, charges about $650 per colour figure, and a subscription fee for reading, about $2,200. Science Advances, a gold open access journal, charges an APC of $4,500, and Archive costs $10 per article to host, but includes some of the greatest research ever produced, and likely some of the worst. Editor's note here. This was a bit of a diversion into meta-science and scientific history. Hope you've enjoyed it as much as I have. Next I'll move back to some actual models and code about the Vishek model and Boyds, I expect. But I'd love to know if you'd like more history and meta content in the future. Thanks again for watching.